I'm Algebra Annie, and I am here to help you be successful in your algebra class. A person who never made a mistake never tried anything new. Albert Einstein. Our learning targets today are, I can add and subtract real numbers.
I want to introduce our next concept by first talking about money. Let's pretend that you worked, and that work you made $1. So we would represent that by you making $1. And then your mom said, hey, you owe me money. You didn't do your chores. You owe me $1. So that would be your mom saying, you need to give me $1. Well, how much money do you have now? You have $0 left. You didn't make anything. Your $1 and you owing $1 canceled each other out. We're going to use the concept of money to help us solve adding and subtracting real numbers. Real numbers are numbers that you could have put on a number line. So we're going to use the concepts of money to help us solve adding and subtracting of real numbers. What did we get out of the money? We knew that every time we made something, but then if we lost that something, they ended up canceling one another out. So for every positive, if I can group it with a negative, they cancel one another out. Let's use this idea to solve the problem -3 plus 6. -3 means I have 1, 2, 3 negatives. This is a positive 6, which meant I had 1, 2, 3, 4, 5, 6 positives. As we learned, for every time you can group a positive and negative, they cancel each other out. So there's 1 group, 2 group, 3 group. They cancel each other out. This is what is left over. That would be our final answer. So our final answer is a positive 3. Using this same line of thinking, we have -13. So -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 negatives. That was a positive 7. So here is 1, 2, 3, 4, 5, 6, 7. Anytime you can group a negative with a positive, they cancel each other out. We are left with these, and they're negatives. So our answer is a negative 1, 2, 3, 4, 5, 6. There were 6 negatives, so our final answer is -6. We're going to use the same thought process to solve -3 minus 7. This number represents -3. 1, 2, 3. This represents -7. 1, 2, 3, 4, 5, 6, 7 negatives. Whenever you can pair up a positive with a negative, they cancel out. I have no positives to pair up with any of these negatives, so nothing cancels out, which means all of this is my answer. I have only negatives, so my answer is a negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My answer is -10 because there were 10 negatives in here. We're going to use the same thought process to solve this problem. -5 plus -7. -5, 1, 2, 3, 4, 5. 5 negatives. This is the number -7. 1, 2, 3, 4, 5, 6, 7. If I paired up a positive with a negative, they canceled out. I have no positives to pair up with these negatives. So all of these negatives are my answer. Since they're all negatives, my answer is negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -12 is my final answer. We're going to use the same thought process to solve the problem 7 minus 10. This is a positive 7, so that is represented with 1, 2, 3, 4, 5, 6, 7 positives. This is a -10, so he is represented with 10 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I can pair up a positive with a negative, they cancel out. So 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, 6 pairs, 7 pairs. I paired them all up. I am left with these left over. They are negative, so my answer has to be a negative. And there were 1, 2, 3 in there, so my answer is -3. Now this is a problem we have not seen before. This is -3 minus a -12. Whenever we have minus a negative next to each other, these turn into a plus. So we have -3 plus 12. You need to rewrite the problem, and then we can solve this using what we know. This is -3 plus 12. -3 is represented with 1, 2, 3 negatives. A positive 12 can be represented with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I ran out of room going down, so I just moved them over. As long as you make sure that you pair up accurately, you're fine. So there's 1 pair, 2 pair, 3 pairs. I paired up 3 negatives with 3 positives. I have all of these positive numbers left over. Since they're positives, my answer needs to be positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 positives left, so my answer is a positive 9. Now we have the problem -2 minus a -9. Again, we do not like seeing minus and negative. We need to rewrite it so that the minus negative turn into a plus. So it's -2 plus 9. This is a problem that I am able to solve. -2 is represented with 2 negatives. 1, 2. A positive 9 is represented with 9 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, as long as all 9 of them are represented here, it does not matter how you write them. So this negative pairs with a positive. This negative can pair with a positive. I'm running out of negatives, so I have nothing else up to pair with. 1, 2, 3, 4, 5, 6, 7. There are 7 positives left, so my answer is a positive 7. So now we're going to solve this problem. We have 3 minus a -6. Again, I do not like seeing minus and negative, so we need to rewrite it. The minus negative turns into a plus. So this is actually 3 plus 6. This is a positive 3, so that's represented with 3 positives. This is a positive 6. This is represented with 6 positives. If I can pair up a positive with a negative, they cancel each other out. There's no negatives in here to pair up with. So all of these are my answer. They're positives, so my answer is positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. Means I have positive 9 as my final answer. Now sometimes you're going to have to solve these with fractions. We know how to solve fractions from a prior lesson. The denominators have to be the same. They are. Since we're talking about parts of 8, that means my answer is going to be in terms of parts of 8. The negatives are attached to the numerators. So this is in theory a -1, and that's in theory a -3. So if we think about -1 and a -3, that was a -1 and a -3. Can I pair anything up? Nothing pairs up to cancel out. So my answer is 1, 2, 3, 4. There were 4 negatives. So my answer would have been -4 in the numerator. This fraction can be simplified. Both the numerator and the denominator share a factor of 4. So I'm going to divide both the numerator and the denominator by 4. So I get a -1 over 2. So my answer is -1/2. So now we need to do the biology application problem. Here we have an iceberg submerged in water. And here is a penguin up here. This penguin is 10 feet above the water. If this is 10 feet above the water, that meant the water line was 0 feet. The biology application problem says this emperor penguin stands on an iceberg that extends 10 feet above the water. Then the penguin dives into the water and drops down to the elevation of -67. So he's now at -67 feet below the water to catch all of the little fishies that are down here. So here's all of our little fishies. The question is, what is the total length the penguin dove? Well, the picture is really going to help us solve this problem. The distance from 10 to 0 would have meant that he dove a total of 10 feet. And then the distance from 0 to 67 is a total distance of 67 feet. So what is the total distance that he dove? He dove 10 and then another 67. He dove a total of 77 feet. The next word problem we're going to talk about is a meteorologist and the problem for them. So a meteorologist reported that the day's high was 17 degrees Fahrenheit, but that its low was a -5 degrees. It wants to know what is the difference between the day's high and the day's low. It wants to know, so 0 is in here. That's 0 degrees Fahrenheit. It wants to know what is the difference. What is this total range of temperatures? Well, if this is a 17 degree difference and this is a 5 degree difference, what is the total degree difference? I dropped first a 17 and then I dropped 5. So I ended up dropping a total of 22 degrees. Now when the numbers start to get really big, and it's too hard to draw all the positive signs and all the negative signs, it's easiest to think about this in terms of money. So I have $52, but then I need to pay somebody, so I need to give up $63. I need to pay $63. I don't have 63. I have 52, which means in the end, I'm going to owe somebody still. I haven't fully paid them. So if I paid 52, how much do I still owe them? So in the back of my mind, I have a little thought bubble over here. I owed them $63 and I paid them 52. How much money do I still owe them? 3 minus 2 is 1. 6 minus 5 is 1. I still owe them $11. So what is 52 minus 63? I still owe them. I owe them $11. So back up to the original problem. 52 minus 63 is a negative 11. Let's do another one. I have $12 in my piggy bank, but I owe my mom $138 because I broke her favorite lamp. So I gave her my 12, but how much do I still owe her? I do, in fact, still owe her. So I know that it's a negative number because I do still owe her. So again, I have a little thought bubble in my head and I'm thinking through, okay, my mom told me I had to pay $138. I gave her the 12. How much does she still want from me? 8 minus 2 is 6. 3 minus 1 is 2. 1 minus nothing is 1. I still owe a lot of money, $126. So I owe, it's a negative, still owe $126. So let's do negative 30 plus 93. It's a really large number still, but the negatives and positives are different spots. So let's think through this one. So I went shopping and I found a really good book that I wanted to buy. So I go to the register and I look in my wallet and I have $93 in my wallet. Well, how much money am I going to have left if I actually buy that book? So there were $93 in my wallet and I would have to turn over $30 at the register. 3 minus 0 is 3. 9 minus 3 is 6. I would have $63 left in my wallet if I bought that book. So negative 30. My book is $30 that I have to pay, and there were $93 in my wallet, meant that I had $63 left to spend. So let's do another one. Negatives represent you owe something. You're going to spend something. You don't have the money. So this is negative $30. I want to spend 30, and then I want to spend 62. If I'm spending 30, I'm in the hole 30, and now I'm spending 62, I'm still in the hole. Well, how much are you in the hole? I owe my mom 30, and now I owe my mom 62. How much do I owe altogether? This is my thought bubble thinking through this. I now owe my mom $92. Negative 92. Last thing for the day that we're going to talk about is absolute value. Absolute value is how far a number is from 0. So our first is going to be the absolute value of 5. How far away is 5 from 0? That's what absolute value of 5 means. So here's my number line. 5 would have been 1, 2, 3, 4, 5. 5 would have been over here. How far away is 5 from 0? It was 1, 2, 3, 4, 5 things away from 0. So the absolute value of 5 is 5. Well, now let's look at the absolute value of negative 5. Where is negative 5? Negative 5 is right here. Absolute value of negative 5 is asking how far away from 0 is negative 5. Negative 5, 1, 2, 3, 4, 5. Negative 5 is 5 spaces away from 0.
What did we learn today? I can add real numbers. I can subtract real numbers. And I look forward to seeing you tomorrow in class.